Hello, everyone. We'll give it about another minute to see if anyone else joins. But thank you for joining so far. Okay, I make it 1 minute past 2 Eastern time, so we'll get started. Hello, everyone, and welcome to the Asphalt Institute Odor Management Tool webinar series. For those of you that don't know me, I'm Paul Soey, Vice President of Industry Stewardship for AI. I want to inform everyone that this webinar is being recorded and will be available on the Asphalt Institute website. For those of you that have not downloaded the management tool, please scan the QR code that you see on the screens. It will be made available at the end of the presentation as well. Next, I would like to thank and introduce our moderator for today's session. That's Shyla Blackketter-Dwyer. Shyla is the Director of Environmental Health and Safety for TAMCO Building Products. Shyla sits on AI's HSE committee and acted as a chair of the task force that initiated the development of this tool. Now I'll hand it over to you, Shyla. Thank you.
Thanks, Paul. And again, welcome to our participants to the first training session for the Asphalt Institute's new odor management tool. Please submit any questions you have through the Q&A function on the sidebar, and we'll get to those at the end of today's presentation. A little background on this tool. It was born out of a recognition that odor issues were becoming increasingly important to member companies, and that odor as an issue is both challenging and complex to understand. Consequently, the Institute engaged SCS engineers to help our member companies and industry members at large better understand the issues and provide insight into how to best manage these issues. So with that, some quick introductions of our speakers today. First, we have Ms. Tia Jeter. She received her bachelor's degree in chemical engineering from the University of Kansas in 2001 and received a Master of Science in Environmental Engineering in 2003. Tia is a registered professional engineer and a project director with SCS Engineers. Prior to joining SCS, Tia worked for DuPont Sabine River Works facility in Orange, Texas, as an environmental coordinator for the ethylene manufacturing unit. Tia has over 20 years experience in environmental compliance field, focusing predominantly on air compliance for chemical, industrial, agricultural, and solid waste facilities. So welcome, Tia, and thank you. Our second speaker is Mr. Paul Schaefer. Paul is the Vice President and Project Director at SCS Engineers. He's also one of SCS's national experts for conducting odor assessments and ambient air monitoring programs. He is considered an expert in conducting air quality assessments of specific air toxics, criteria pollutants, as well as odor and odoriferous compounds. Paul directly manages the operation of a laboratory quality olfactometer. I can't say that word very well. That means ASTM and EN methods for odor assessment. In addition, he has developed state-of-the-art measurement techniques for surrogate odor compounds specific to various odor sources. Paul has an in-depth experience in interfacing with regulatory agencies regarding the performance of monitoring systems, air sampling networks, and continuous process monitors, which are operated for his clientele. He has direct work experience with several air pollutant control districts, air quality management districts, and the California Air Resources Board and EPA. Paul has provided expert work services on several odor projects in litigation and provided expert testimony in cases. So with that, we appreciate Tia and Paul's time today, and I'll turn it over to them for their presentation.
Well, thank you so much for the introduction, Shyla. Greatly appreciate it. Very much looking forward to giving this presentation today, and appreciate Asphalt Institute allowing us to do this. So we're going to start off and just kind of talk about some facts about odor pollution prior to getting into what this webinar, webinar 1, is going to be about. So So just some general facts about odor pollution. A large portion of complaints issued to regulatory agencies concerning air pollution involve an odor component. This is over 50% of complaints, according to multiple different agencies that we've looked into. However, it's not recognized by EPA as a pollutant. Odor isn't. It's generally regulated at the state and local level. It rarely has a direct physiological impact, and perception of odors can differ by populations. Once perceived as offensive, though, odors can have secondary impacts that arise, such as nausea and headaches. Odors are difficult to quantify through analytical methods. There is no single odor molecule. It's also difficult to isolate sources. So, ways odors are regulated. Different types of ways odors are regulated depending on where you are. So annoyance is a subjective category. Complaint criteria, number of complaints, frequency of complaints over a certain amount of time, ambient odor concentration, or odor detection thresholds, and we'll talk a little bit more about that as in later in the webinar, as well as ambient odor intensity, done through analytical testing, ambient odorant criteria, so the use of a chemical surrogate for odor. This is often common for H2S. Episode duration frequency criteria, odor hours, how often or what percentage of the time are you impacted by odors? Source emission criteria, chemical surrogate at the source. Best available control technology criteria, so different industry standards for controlling odors. So some common odor nuisance law. We're going to look real quick at public nuisance and the difference between public nuisance and private nuisance real quick. So public nuisance, it's an unreasonable interference with the public's right to use and enjoy public spaces. So health, safety, comfort, or convenience of the use of air, land, and water owned by the public. There's a consideration of the cause of the harm and interference with the public interest at large. Anyone or any facility who creates a public nuisance can be held responsible. And this is important. Regulatory compliance is not a defense. Just because you're in compliance with all your regulatory issues doesn't mean that you can't be subject to nuisance odor situations. Well, private nuisance, unreasonable interference with the use and enjoyment of your own land. So the land you own. Substantial injury, one that amounts to more than a slight annoyance or trifling interference. Often involves balance or competing interests in private nuisance cases. The source of the alleged nuisance must originate somewhere other than the complainant's land. And again, regulatory compliance is not a defense for private nuisance. So, webinar 1 of 3, just going to go, this is what today's webinar is going to cover. We're going to describe what is odor. So brief description of how the sense of smell works. How is odor defined? Discussion of odor detection thresholds and odor characterization. We're going to talk about the chemistry of asphalt odors. Summary of what compounds detected in asphalt fumes that have odor potential. Potential asphalt odor sources. Overview of the potential sources of asphalt odors. And discussion on factors that affect odor transport. So asphalt odor generation and transport. So, what is odor? Everybody likes a little Shrek reference, but what is odor? A perception experience when one or more chemicals come into contact with odor receptors on the olfactory nerves. This is important, the fact that odor is a perception. It's what is perceived by a human or mammal, and it's perceived different by different populations, and it is somewhat subjective. So, our sense of smell, how we smell. Our sense of smell relies on specialized cells in our nose called olfactory receptors. We have an olfactory bulb. These receptors send signals to the olfactory bulb in our brain where scent processing occurs. Even to this day, how this process works, we're still learning a lot about, and it's a somewhat of a black box in regards to how the brain works and the scent processing occurs. Studies on the interactions between individual odor receptors and multiple chemical odorants found that an odor receptor can recognize many odorant molecules, and an odorant molecule can bind to and be detected by multiple odor receptors. So again, a little bit more about our olfactory system. Although there are only a few hundred active odor receptors, humans can recognize over 10,000 different odors. Combination of odor molecules and activated odor receptors create a receptor code, and that receptor code creates a unique pattern for a specific odorant, and that's how a kind of a low-level description of how the brain processes odors. So, what conditions are necessary for odor perception to occur? For one, there needs to be an odor-generating source present. The odorant molecule is generally a volatile compound. The odorant's molecular weight is less than 300 Daltons. This is some detail you probably won't need, but we're just providing that information. This information is in the tool. The odorant's vapor pressure is greater than 0.01 kilopascals at 20 degrees Celsius, and the odor molecule has a moderate to high hydrophobicity, so somewhat hydrophobic. All right, so the mixture effect. So what happens when different odoriferous compounds are present at the same time? So some olfactory neurons only respond when two or more odorants are present. For example, compound A, you don't have any odor, no odors detected. Compound B, no odor, but when you have compound A and B together at the same time, an odor is perceived. So that's considered the mixture effect. Mixtures can have perceived odors that are not simply the sum of the individual components of odors. So some mixtures can actually inhibit the perception of other odors, and some mixtures of compounds can actually increase or the perception or the sum of the parts is greater than the individual compounds on their own. Okay, so how do we define odor? So the main ways we define odor are within this table. So odor characterization parameters. So first off, concentration, very important parameter regarding odor. So odor concentration is quantified by determining the amount of dilution required to bring odorous air sample to a detection threshold. This is often called the odor detection threshold of a specific compound. So or the dilution to threshold of an air sample defines its odor concentration. Intensity. Odor intensity refers to the perceived strength of the odor. It's a quantitative measurement of intensity, requires comparison of the odor air to a standard. Typically in butanol, an odor-free air is the standard. A qualitative scale can also be used to describe intensity, with 0 being not perceptible to 6 being extremely strong. Odor character. Odor character describes what the substance smells like. So, for example, fishy, hay, nutty oil, creosote, turpentine, all of these things are descriptions of odor character. Hedonic tone, essentially, whether or not it's offensive or not, the degree of unpleasantness of an odor. It's a subjective judgment. Certain people, my wife, for example, loves the smell of gasoline. Some people do not. We even have an employee within SCS that I work with directly who loves the smell of hydrogen sulfide. I think she's nuts, but she likes it. Okay, odor detection threshold. This is just a greater detailed description of what we were just recently discussing. So odor detection threshold, it's concentration of odor. The lowest concentration of an odorant that can be detected by a person. This odor detection thresholds are established through testing. Hydrogen sulfide can be detected at a concentration at as low as 0.5 parts per billion or 0.0005 parts per million by some people in populations. So butanes are not detected generally until a concentration over 5,000 parts per million volume. So certain compounds have a significantly lower odor detection thresholds than others. Sensitivity to odor is subjective and varies from person to person. Detection thresholds established for compounds vary, and for this reason are frequently listed as a range of concentrations. So odor intensity, essentially the perceived strength of an odor sensation, oftentimes described as in a way as 0 being not perceptible to 6 extremely strong. More intense odors are likely more annoying. Even pleasant odors can be annoying at high intensity, and offensive odors can be annoying at low intensity. So it's a combination of odor character as well as odor concentration that's in play. Odor character, essentially what does the substance smell like? So, there's all sorts of categories from smells. The ASTM data series DS61 provides profiles 180 different chemicals. Examples of descriptors, like we discussed before: fishy, hay, nutty. So this is a way of trying to establish relationships between potentially a source and the character being perceived downwind. Hedonic tone, essentially how pleasant or unpleasant it is. It's influenced by subjective experience, like we discussed before, how frequent the occurrence is, odor character, odor intensity, and duration. So hedonic
Hey,
tone
Paul.
is yep.
I don't think your slide moved forward.
Oh, shoot. Sorry. Thank you.
You're good.
There we go. Hedonic tone. So influenced by subjective experience, odor intensity, and duration. So hedonic tone is influenced by all the other different types of parameters and characteristics that we discussed. And so some odors that are pleasant at low concentration, at high concentration, can be perceived as not okay. So baked bread smells good at low concentration, but some of the chemicals in baked bread smell essentially like vomit at high concentration. So that's an example of how hedonic tone can change with concentration. Okay, so we're going to discuss some of the chemistry of asphalt odors now. So what are the chemicals related to asphalt odors that can, cause odor events? So hydrocarbons are one class of compounds, and here the examples are on the right-hand side of the table. Oxygenates, including aldehydes, ketones, and esters. Nitrogen compounds, amines, nitriles, sulfur compounds, mercaptans, thioethers, carbonyl sulfide. Most of the time, sulfur compounds generally have very, very low odor detection thresholds. Halogenated compounds, aliphatic compounds, chlorides, bromides, and inorganics. Hydrogen sulfide is an example of an inorganic. H2S has a very high odor detection threshold, or very low odor detection threshold, able to be detected at very low concentrations. Okay, so asphalt odors, some of the data we evaluated in development of the tools. So we looked at quantification of potentially odorous volatile organic compounds from asphalt binders using headspace. So Mr. Lang and his group put together a really quality a description of asphalt emissions, and we utilized a bunch of that data, and we combined it with odor detection thresholds to determine which of the compounds have the highest potential relative to asphalt sources for generating odor and odor events. So what compounds had high odor potential? For one, sulfur-containing compounds. So butane, here's some butane thiol, carbon disulfide, and you notice how we provide an odor detection threshold range, as well as the odor character related to that specific compound. The reason that we provided a range is that depending on the test method and the source, from American Conference of ACGIH, American Conference of Governmental and Industrial Hygienists, to EPA, 3M, various types of journals, you can find large ranges of odor detection thresholds specific to a compound. One thing that's important to note, if you are doing an assessment, it's important to stick with one list or one source of odor detection thresholds, because the method they'd use to determine odor detection thresholds could be very different and provide different ranges depending on the study that you're citing. So if you are doing an assessment, make sure you're using one list and not bouncing from list to list, because you're going to be comparing apples to oranges. All right, so aromatic compounds, low to moderate odor potential: phenol, styrene, and toluene. Some are listed at fairly low odor detection thresholds, but in general, compared to thiols, mercaptans, and sulfonated compound, a much more moderate to low odor potential related to these compounds. And then the compounds that may exist in high quantities, but potentially aren't a major source of your odor profile or what would cause odor events, is 1,3-butadienes or aliphatic compounds and fluorinated compounds. Essentially because these compounds have significantly higher odor detection thresholds than compounds listed before. So potential asphalt odor sources, and I believe TA, you're taking over from here.
Yes. So I will touch base on a few of the kind of common sources we find in the asphalt industry where you could maybe produce odors. So the first one we have here is your asphalt loading, unloading, and storage. So kind of as this cartoon kind of depicts, as you load liquid into a vessel, whether that's a storage tank or maybe you're loading into a truck, you're displacing the vapors that are in that vessel and pushing them out of some sort of event, could go on a stack. Wherever those vapors are emitted is a potential source of odors that will be released to the atmosphere. We have seen in some cases these storage tanks, a lot of times, especially like in a big facility, they're controlled by maybe it could be a flare for some sorts of facilities like refineries. Maybe it's a mist eliminator. So there are certain controls that maybe can reduce these odors out of these stacks. Or in some cases, it could just be an open vent. We did testing at a facility where they were actually unloading a truck of hot asphalt. And in the process, before they start pumping out of the truck, they open a vent on the truck. That way you avoid pulling a vacuum and kind of crushing it like a can when you turn your pump on. And there are, 2 to 5 minutes between when that vent is opened before the pump starts that you have hot asphalt and visible fumes and odors that can escape through that vent. So these are kind of sources that sometimes are controlled, sometimes they're not. Typically there'll be an intermittent odor source. So it really kind of depends upon the frequency you're receiving trucks or loading to a tank. Asphalt mixers. So most of you are familiar with this industry. These mixers are used to combine liquid asphalt with many types of different compounds. It could be aggregates, for paving. It could be additives to make a different type of coating, recycled materials. But generally in these mixers, you're tumbling around the asphalt, agitating it at pretty high temperatures, which does create the potential for asphalt fumes or odors. These are common at hot mix asphalt plants, cements and coating facilities, shingle production plants, terminals. They all may have these mixers there. Again, these may commonly be going through some sort of an air pollution control device. And in some cases, if that air pollution control uses a form of incineration or like a thermal oxidizer, you could get fairly good odor control on this source. If it's a mist eliminator, you may not get as good of an odor control. And if it's not controlled, then it's definitely going to be a pretty strong source of odors. Asphalt saturators and coaters. So coaters, this is where you're applying the asphalt to a substrate, typically a fiberglass mat. Frequently you'll see these at shingle production lines. You do have kind of an open vat of hot asphalt, which has a potential to generate fumes, which would release odors. Sometimes the issue with these coaters, it can be hard to enclose them completely and try to capture those emissions and control them in some way. This is kind of inhibited because you have to get that substrate, it has to go in and out of the coater. So totally enclosing that can be challenging. So sometimes these coaters are a source of our fugitive odors. And we'll talk about that on another slide, but you might have a fugitive odor source within a building. And then you're further looking at how you control that building. Saturators are another common source we see in the asphalt industry that can be a source of odors. They're typically a large volume of asphalt in a saturator, which is why it can be something to be mindful of. They are frequently controlled though, and they are frequently controlled oftentimes by some sort of a control that uses incineration or oxidation. So while it's being controlled by that type of a control device, your odor risk is probably pretty minimal. The things I would be cognizant of is if you have a malfunction of that odor device or downtime, if you have an uncontrolled saturator, it's a high volume of asphalt at high temperature with the potential for an odor episode to occur if you have no control. Asphalt applicator. This could be surface application, whether you're paving a road, or this could be application of asphalt to, say, some sort of a sheet, like a laminate or sealant applicator in roofing manufacturing, or you could be applying to like a roofing underlay. You might have some sort of an asphalt application on that. All of these are opportunities for asphalt fumes and odors to be generated. The level of perceived odor is typically impacted by many factors, some of which we kind of talked about here. The temperature of the asphalt, typically the hotter the asphalt, the more potential to volatilize these compounds that can be considered odorous and create potential for odor. The surface area of application obviously impacts, the amount of asphalt and the surface area, which would increase odor. And then the potential to enclose it. Obviously, you're probably not going to be enclosing a road that's being repaved to try to control those odors, but we could try to enclose a laminate applicator or sealant applicator, and transport those odors to some place where it can be either reduced, or maybe you emit it at a higher release height through a stack to try to reduce ground level impact. So there's ways to try to mitigate some of these sources. Asphalt oxidizers, also called a blow still. If you're not familiar with this, in a blow still, you're bubbling air through liquid asphalt in a process vessel. Basically, you oxidize the asphalt, and it changes the softening point and penetration rate of the asphalt. Odors can be generated in this process. You are bubbling air through liquid asphalt, so you're kind of increasing the potential to volatilize or move some of these compounds into an airstream that could potentially be emitted. Ideally, by regulation, most of these blow stills are controlled, again, through probably some sort of incineration or oxidation. While that control device is operating, you probably have a low odor risk. If you have a malfunction of that control device or downtime where you have a blow still operating without control, then you would have a potential for an odor risk to occur during those moments. And then odors from other air pollution control devices. So I kind of hit on like incineration, combustion. Those do a pretty good job of breaking down most odorous compounds to less odorous compounds and reduce odor risk. But there are certain controls that don't necessarily do that. So one, mist eliminators, these are also called coalescing filters or candlestick filter. They're commonly used in the industry to control asphalt fumes. And they primarily work by controlling particulate matter. So you're basically filtering the fumes through filters, and the PM or the particulate matter sticks to the filter, and then you have cleaner effluent leaving the vessel. So you can see some reduction in odor if you have a mist eliminator that's being maintained and properly cleaned, where you have captured some of those particles on your filter that's reducing the odor that leaves. We have seen some, however, through some testing done at sites, that if your mist eliminator has not been maintained, or maybe you have a lot of accumulation on your filter, it can actually add to odor. You would see this if you had an example of a facility that had maybe multiple processes that could be controlled by the same mist eliminator. If one of those processes had a really high odor concentration, that high odor potential gets adhered to on that filter. And then if afterwards you were to even run clean air through that filter, you could potentially volatilize some of those odors and release them through the filter. So mist eliminators can reduce odor if they're maintained, and you're changing out those filters on a frequent basis. Another one we saw were bag houses, which is kind of an interesting one we saw through some testing. This is bag houses post asphalt application. So in this case, if you have, like, I would say as an example, a shingle production line where you have a coater and you're applying asphalt, and after the coater, you have a blender where you apply your aggregate. Typically, the fumes from the coater would ideally go to a mist eliminator, potentially for control. So those asphalt fumes. And the blender is then controlled by a bag house, which is trying to reduce particulate matter off the granulars that you put on the shingle. In this case, we've seen the potential for some of those fumes to get carried over from the coater and actually go out through the bag house stack. So if you're doing a site assessment, and you're wanting to test and try to identify where are my odor sources and where can I reduce odors, don't leave out looking at those bag houses, because they can be potential sources. I think your screen got shifted over, Paul. There you go. So yes, we can potentially see odors from these air pollution control devices. So there's something to keep in mind. get our presentation back up here in just a second. There you go. The next one is good. The fugitive. There you go. Fugitive odors, and I think this is my last slide on sources, is another one, and you'll see that it's at many types of facilities. So the first one I talk about is kind of building fugitives. So this is more if you have a process that's inside, could be a shingle production line, could be coating or cements and coatings facility, or anything that's inside a building, and you have odors being generated inside the building. The building then becomes kind of a fugitive source of odors, where these odors may be emitted through a fan, like a wall fan. It might be emitted through somebody opens a door. Some of these sites, some of these material or processes are very hot. So in the summertime, these facilities like to open big garage doors to let air through. It's more comfortable for employees. By doing this, however, you've created a new pathway for odors to kind of escape and move away from the facility through these doors. So we can see fugitive odors from these buildings, and they can be a large volume of air to try to control or reduce. So it can be challenging to kind of build a profile on how we reduce those odors. Other fugitives we see are just process fugitives. These I would refer to as if you have a refinery or just any enclosed piping where you're moving hot asphalt from like a tank to another vessel. You have fugitive losses through valves, flanges, pump seals, like any other fugitive loss. The odors will escape through those. Facilities can have LDAR programs in some cases if they want to try to reduce that, but it is a source of odors, and something that some facilities like to think about how to manage that if it's potentially causing a downwind impact. All right, so that was kind of some of the sources we see potentially generated odors in the asphalt industry, and now we're going to talk about kind of how those odors are transported or move away from your facility. So primary factors that impact odor transport, it's very similar to any other air pollutant. If you've ever done dispersion or transport of any other air pollutant, the method of the release is an impact. The meteorological conditions at the time of release, as well as the local topography and facility structures can impact how that odor will be transported from your facility. So method of release, you have your odor emission rate. This is a function of the concentration of odor in the stream and the volumetric flow rate. You have to consider both because you could have one stack with a really high odor concentration, but if it's a super low volume, it may not be that impactful. Conversely, you could have a stack with a low odor concentration, but a very high volumetric flow rate that could cause a problem. So you look at both as your odor emission rate. The release velocity looks at the potential for mixing and dilution. So ideally, the faster something leaves a stack or a fan or a vent or a door, the better potential is to mix and dilute with the air, which can reduce that odor concentration that somebody downwind could potentially perceive. So mixing and dilution is a good thing when we're looking to reduce odor. The orientation of the release, this talks to, is it going vertically release or is it a horizontal release? So vertical would most likely be a stack, or it could be a fan on top of the building. Horizontal would be like a wall fan that blows horizontally out the building, or maybe it's just a door that's open and odor's meandering out that door horizontally. Ideally, vertical release will get more mixing and dilution than horizontal. The release height also impacts the potential for mixing and dilution with air. The higher the release, generally the better chance you have of that odor diluting and mixing before it gets to the ground. So higher is better, generally speaking. Similar with release temperature, the hotter something is, the more buoyant it is. That buoyancy kind of gives you an additional effective release vertical that can help increase the likelihood of mixing and dilution, which is a good thing for reducing odor. Your meteorology obviously plays a big impact on that potential for mixing and dilution, really. So wind speed, higher wind speed creates more mixing. Low wind speeds is generally when you're going to have a higher risk of offsite odors downwind from your facility. The wind's not really moving, it's not mixing, it's just kind of a low and slow, and so you could have higher odors perceived on wind. The wind direction is also obviously very important to tell us which way could it go. Wind direction is something that we highly suggest a lot of our clients put in met stations at their facilities, where at least you're recording, especially if you have potential odor issues. If you have a met station on site and you know which direction the wind's blowing and there's a complaint on a day and the wind's blowing the opposite direction, you would have proof that it's not coming from me, because I have my own met station that shows the wind was blowing out of the east and your hit was in the wrong direction. So direction obviously plays an important role in where the odor may transport to, and the atmospheric stability has to do with the vertical movement of the atmosphere. Less stable generally means more mixing and diluting. The more stable an atmosphere is, it doesn't mix, and so it's more potential for odor. This picture just kind of depicts that atmospheric stability I mentioned on the previous slide. The little diagrams are supposed to kind of show you visually what a cloud would look like under that kind of a condition. So unstable, we have a lot of vertical movement in the atmosphere, which is why you see the cloud kind of goes up and down. That would be a good condition for mixing, dilution, less odor impacts on that kind of a day. If you see clouds are very flat, not a whole lot of vertical movement, we have a pretty stable atmosphere, probably not a lot of wind. Those would be the days or the moments when you would have more potential for downwind odor. And topography or facility structures. So the topography affects, how the wind will move. If you're in a valley, it may dip down if it's a heavier air. And it also impacts the surface roughness. So if you think about like an open field, like a soccer field, the wind can blow just straight across the field, doesn't mix a lot. If you take that same field, planted a bunch of trees, now that wind has to move around all the trees as it's blowing through, and you get more mixing and dilution. So it all kind of plays a role in how the odors can transport from your facility. We also see this with structures. This could be a building, it could be a large storage tank. If you have a stack next to a building and the wind blows over the building, you get this side on the downwind side of the building where the concentration gets pulled down to the ground because there's a lower pressure on the back side of the building, and that can increase the ground level concentration on the back side. So we can get the same effect from large storage tanks, any other big process vessels. You can have an impact, especially if you have a release near the building. So that might be a moment you think about increasing stack height. Do we change how this is released to try to reduce that potential? And that was kind of how odor is transported. Very high level, very, very brief touch on how the odor can move from your plant. We kind of touched on the chemistry of asphalt, what sources in the asphalt industry are creating odors, and what odor is. So we have some future webinars coming up. Webinar 2, we're going to touch on odor measurement and assessment. That's scheduled for March 17th. If you haven't gotten, there's a link to register for that, which we could probably resend out afterwards, or I'll talk to Jacqueline about that. We will talk on odor monitoring, whether that's direct observation or odor panels, chemical surrogates, how you complete an odor assessment, and go through some case studies. Those are always my favorite on odor assessments that have been done. Webinar 3 is not yet scheduled. But at this point, we're planning to talk on odor control. So we'll talk about the different technologies that can be used to reduce odors. How do you write an odor control plan for your site? We're seeing there are some states are coming out with actual regulatory requirements now for specific industries to develop an odor control plan. So we will kind of walk through what that looks like, talk about some community outreach, and then provide a couple other additional case studies.
Thank you, Paul and Tia, and thank you to the SCS engineers team. I don't actually see any questions in the Q&A at this moment. If you do have questions, feel free to reach out to, you've got Paul's email there, Tia's email there, or Jacqueline set up this meeting and she's got an email address. So if there is a question that you think of, feel free to contact them, and then we can either address them directly or maybe work them into the next sessions to make sure those questions are addressed. But really appreciate everyone's participation today. I believe, yeah, so if you haven't had an opportunity to download the document, there's the QR code there. And then as mentioned, the next session on March 17th, opportunity to sign up and continue this learning process. To say anything else, folks? Well, we really appreciate everyone's time and participation today. And with that, Happy Tuesday. All right.
Thank you.
Paul, Jacqueline, anything else we need?
I think we're good.
No.
All right,
No
thank you,
questions have come
guys.
in.
All right, thank you.
Goodbye.
Thank you.